Hey everyone, happy Monday. Some people were just asking me, some were having some issues with the Lesson 17 formative. Thank you to those who have already sent it in. I appreciate that. And if you are having troubles or you sent it in and you left some questions blank, I'm going to go through some of the questions right now just to give you a little bit of help. And let me know if there's ever any instances like this where you're getting really stuck. I'm happy to make a quick video just to send it to you, or video conference. So if I go through this and it doesn't make sense, let me know tomorrow. I'll be happy to video conference with you anytime. So let's look at this first one when we have a potential difference of 8,000 volts. The plates are 5 millimeters away, and we want the acceleration. Well, if I want acceleration, I know that force is equal to mass times acceleration. So I know this. I know here that force is equal to mass times acceleration. That's my Newton's second law, but I also know that force is equal to QE. Well, they're equal, so then MA equals QE. And if I want to solve for acceleration, acceleration is just going to be QE over M. But I also don't have E in that question, but I do also know that E is equal to V over D. So I can plug all of this stuff in, so Q V over md will find me my acceleration. So you could plug all of that in and find that acceleration. If you have any issues, let me know. For the second part, we want the final speed. Well, final speed means I'm going to have to look at my change in energy. So change in energy, my potential is going to equal the change in energy of my kinetic. Well, potential in terms of electrostatic potential is QV and 1/2 mv squared. This is a small v, this is a big V. Let's make it really big. And I want to solve for v, so I have to multiply both sides by 2, divide by m, and then square root. And then that'll help me find my velocity in this instance. And I have all those things given to me there. For question 2, well, a lot of people were confused on why my answer here is 0. Well, it's 0 because if I have two parallel plates, the big issue is that if I'm moving parallel to the parallel plates, it doesn't actually require any work. So what that means is that if I have a parallel plate there and one there, and across this, from here to here is 75 volts. Well, that's if I move the entire way across. So let's say I'm going from, say, point A here to point B. Well, that doesn't change anything. That actually should just be 0. I'm not doing any work. Your work has to be done perpendicular to the parallel plates. So that's why A is just 0. Now for B, we're only moving 3 centimeters. So let's say we move from here, and we'll move only 3 centimeters. Well, I don't actually get this full 75 volts. I only get a portion of that. So when I'm actually solving for it, my change in voltage is going to be 3.0 centimeters over 6.0 centimeters times 75, which is 37.5 volts. I don't actually get all of that, so that's why it threw some people off. Then you can find your work, and your work is just going to be QV. So plug that in as your 1.60 times 10 to the negative 19 coulombs per electron, and multiply that by your 37.5 volts. So that's how we would go about finding that in B. For C, 2C, it says that the proton is released at the positive plate. What speed will it have when it hits the negative plate? Well, that's moving the entire distance, so now I actually can use a voltage of 75 volts. So again, here I'm probably going to use my change in energy potential. It is change in energy kinetic. QV is equal to 1/2 mv squared. So that's all good to go. No issues there. And we're still being able to solve for this V. So V is equal to 2Q big V over M all square rooted. Good to go. For 3, I actually want to draw it out. So here, in 3, an oil drop whose mass is that accelerates upwards. So it's actually moving upwards. And what's going to cause it to move upwards rather than just falling from gravity is going to be our electrostatic force. So if I draw this out, a free body diagram is really helpful. So what's pulling it up? The electrostatic force. What's pulling it down? The force of gravity. So overall, from Physics 20, we were able to write equations. So our overall F net is going to be our Fe, we'll say that that's the positive, minus Fg, that's pulling it down, so that's going to be the negative. Well, the formula for F net is Ma, Fe is equal to Qe minus Fg. Well, Fg is on your formula sheet, it's Mg. So I want to solve for my charge here. So I have to manipulate, so I'm going to have to add Mg to both sides. And then I'll have to divide by E. So, all said and done, Q is going to equal Ma plus Mg all over E. Oh wait, don't have E. Well, you can do a couple things. You could say, okay, well, E is actually V over D. And then solve for it and plug it in. That would be my best recommendation. And you want to plug all of that stuff in. So here, if you plugged E in, that's fine. If you just get one big equation, you'll actually get this. D times Ma plus Mg all over V. That's actually just like plugging that in there. And then when you divide, you do the reciprocal. Or you could just get a numerical value in there. And you get Q is equal to 0.0350 meters. That's the distance. And then times your mass, 5.70 times 10 to the negative 16, times your acceleration, which is 2.90 meters per second. We'll add it to our mass again, 5.70 times 10 to the negative 16 kilograms, times gravity, 9.81 meters per second, and we'll have to divide that all by our 972 volts. So Q ends up being 3.2 times 10 to the negative 19 coulombs, which, when I find my number of electrons, I can divide it by the elementary charge, which ends up giving me 2, so 2 electrons. For that last one, same kind of thing. Here, the key thing is that when this oil droplet is in between them, the student adjusts the potential difference of the plates so the drop actually becomes stationary. So what that means in terms of this problem is that if I draw a free body diagram, well, my Fe is going to be in balance with my Fg. So those two have to be equal but opposite. So Fe is going to equal Fg. Qe equals Mg. Again, don't have E. Q V over D equals Mg. Solve for Q. Mgd over V. Plug it all in, and we should get our beautiful answer. So again, I appreciate all of the people that actually reached out and said, I do need a little help, Mr. Jones. Please let me know. So this is a really easy thing for me to do. I hope that this is helpful.